Okay, now I want to prove to you a statement, and it's the sum of the digits is the same before and after a swap. So when we look at the sum of the Siteswap S, and the Siteswap is 1 and so on to 1. Ja, das ist schrecklich geschrieben, kann man so machen.
Okay.
Das ist ja nicht so eng, also schlecht aneinander schreiben. Okay, wir machen es einfach nochmal. So now I want to prove to you a statement. It's about the sum of the digits involved in a pattern, and that the swap, this operation swap we just learned, is not affecting it. So it's still the same. So when we got a pattern, I'll call it S, and it's from, it starts with bit 0, bit 1, and so on. Bit 1. And the period is, of course, P. So we define sum of all these digits like this. We just take the first one, then the second one, and so on. And we go up to 2 minus 1. And
Da fehlt ein O. Bei Periode.
period. Yeah. I just. Okay.
It's gonna be one of those things, you know?
Yeah. Ich glaube, ich lasse irgendwann die ganzen coole Informationen fallen, konzentriere mich nur noch auf das Schreiben, das ich schon an der Seite. Okay, wir probieren es noch ein drittes Mal, oder? Das dritte Mal? Okay, now we look at a statement. This statement is about the sum of pattern. And I claim that the swap operation is not changing the sum. So, what is the sum? We got a Siteswap, like this. And what we do, we define sum as all the digits together. Just add them one by one, and we can write that shorter as this. We start from 0, go to p minus 1, and we add all those together. So this is the sum. Just for example, if we have 4 for 1, the sum of it is 4 plus 1, which is 9. Okay? Nothing special so far. But now let's have a closer look at the swap operation. So I will start with a pattern S, and I will change it with a swap operation to a pattern S strich. And this operation is happening on beat A and beat B. And I can't swap two objects which are on the same beat, so one has to be lower than the other. And the first thing that we notice when we look at it is we have our SA here, and we got objects here, so B's, and we got SB here, and here's our BP, here's our BA, and then we also got the beat SA plus A, and here we got SB plus B. And this one will land right here, and this one will land right here. So I can write it down. So SA plus A. This is only telling me the beat. So on beat A, I'm doing the throw SA, which is specific height. And it's the same. I just want to know where this particular throw is landing. And since I started at beat A, I have to count them in order to get the right state here. So yeah, we got this, and we got also SB plus B. Okay, I could write down the same, but it makes no sense. And in the swap operation, I now have that this row, I'm going to call it a strich from A, this will be A, this will be B, this is strich from B, and this is the same as A plus A, and this is B plus B. And since we changed them, they go to the same B, but from another object. So this one is A plus A is this, right? And it's the same as B strich, as B plus B. And this one is the same as this. Okay? So this is what we actually do. And if I look at this, I can add them together. So the left side and the right side. And now what I do is I subtract B and A, and I come to this expression. That the throw from BA and the throw from BB added together are the same as those two. Okay, and this is a really good equation that we can use later. So now we have a closer look at the sum itself. When we look again at this equation, this has to be true. If we do a swap, this is true. And now write down the sum of x. It's this here. There's E. And I want it to be the same. This is what I wanted. I don't know yet if it's true. So also, we got the same period, and we call it S strich from B. Okay, and this is the sum of S strich of this B. And now what I do, since I only change two throws, I can subtract all the other throws which are the same. So I write down minus SE for all which are not equal to A and not equal to B. So I end up with as A plus as B. And here I got SA strich plus SB strich. And since I know that those two are the same, but it doesn't matter which, the order doesn't really matter, it's more about the sum of them is the same. This is something that we proved, that we showed right here. It has to be the same when I do that. So this is true because of the equation of the swap operation.